Hey everyone, today I'm going to be showing you how a harmonic drive works. I have a little car here that's pretty neat. You can see I can just give it one little push and then it has enough energy to drive off the edge of the table here. So the way this is working is through the power of gear reduction and this flywheel in the center here. So this green wheel is a hefty solid piece of metal. So we can store energy in it as angular momentum if I try to spin it like this. But this is a hard way to get it spinning. An easier way to do it is to use gears. You can see these wheels have a connection with this white gear here, and there's a smaller gear connected to that. So this white gear is connected to this brass colored gear, but the brass gear has less teeth than the white colored gear. With a slight turn of the white gear, it makes that brass gear do a full rotation. So then that brass gear is connected to a larger gear, so that with one spin it makes a larger one go in a full rotation as well, with only a slight turn of the wheels. And then we connect this larger gear to, again, a smaller gear that has less teeth, and this amplifies the turns again. So with one turn of the wheel, I get 50 turns of the green flywheel here. But to get those returns, it costs you something. It takes more torque to turn the wheels now. See how hard they are to turn compared to the back ones that aren't connected to anything? So you can use gear reduction to increase rotational speed and decrease torque, or decrease rotational speed and increase torque. You can do all sorts of things with gear reduction. It's the way almost any mechanical system works. But these gear reductions take up space and have a decent amount of weight and mass to them. But in some applications you need high gear reduction, but you have limited space to put it in. So in 1957, an inventor named Clarence Musser invented an ingenious device called the strain wave gear, which is also called a harmonic drive. This red piece in the middle can bend a little bit by this moving oval in the center. And as it deforms, notice that the red gears move to the left a little bit. So at the next rotation, they're in the next groove. So with a full rotation of the green oval, you've only moved the red gear by 2 grooves. So what does this look like in real life? Well, I have a 3D printed version of this that was created by Emmett Lalish. I'll put the link to it in my description. It's really cool. It can be 3D printed pre-assembled, so you just print it as one whole working piece. The inside uses orbital gears that have a herringbone pattern so that they can't slip out. This gear here can only be 3D printed because of the fact that the gears can't be removed. You can see how this outer shell here is very thin. It's only around 2 layers thick. I printed this with a 0.2 millimeter nozzle. But the end portion here is rigid, so you can connect something to it that you can turn. So we're not counting the rotations that these gears are making in a circle, but we're seeing how many rotations this center gear is making compared to this outer one here. You can see as I turn it how I can spin the center really fast, but it only makes a few turns of the outer shell. This is amazing. I outlined one of the teeth in this outer gear here, and you can see it move along compared to the tooth on the outside here. But what makes these harmonic drives special is the space they take up. In the same volume for a harmonic drive, you can get around a 320 to 1 gear ratio compared to only a 10 to 1 gear ratio with regular gears. So they use these gears in applications where you need to save space and weight. For example, the wheels of the Apollo lunar rover use these harmonic drives. So if you're wanting to make one of these for yourself, then you can easily do it with the Creality 3D printer. Creality sponsored this video and sent me their new Ender 3 S1 Pro. I already owned an Ender 3 before this sponsorship, but I love the S1 Pro. The nozzle can reach up to 300 degrees Celsius, and it has a full metal gear direct extruder. So you can print any material you want. And also my favorite thing about the printer is the CR Touch automatic leveling. It has a 16-point leveling that will automatically level the bed for you to make small, minute adjustments in the Z-axis. It also has this bright LED light at the top so you can actually see what you're printing. And also the best thing about it is it was super easy to assemble. It took me less than an hour after opening the box to be printing something from it. Also, it supports the Sonic Pad, which has a 7-inch touchscreen, so you can control it from the web and do real-time monitoring and time-lapse photography. I highly recommend Creality printers, and this one especially. It's perfect for beginners and pros. So if you want to check out the Ender 3 S1 Pro and other Creality printers, click the link in my description. And thanks again for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe if you haven't yet, and hit the bell so that you can be notified when I release my latest video. And thanks for watching, and we'll see you next time.